Today I don't feel like doing anything. I just wanna lay in my bed. Don't feel like picking up my phone, so leave a message at the tone. 'Cause today I swear I'm not doing anything.
Hey, what's up, guys? Welcome to week 3 of distance learning. Is it our third week already? It only feels like it's been 100 years, right? Well, today we are going to go over our test and the correct answers, and I'll try to do that as quickly as possible. Most of you guys did really well on the test. I was super impressed with your scores. Our enrichment projects, you can't really read that, but we're going to talk about them on Wednesday. I feel like that's a good day since it's a little bit shorter. So have your one sentence pitch ready to go, ready to be shared with the class, and we will determine our enrichment groups tomorrow. Moving on, if you would pull out your exam so you can follow along with me. The first question asks us to write a recursive and explicit function for this guy. So the first thing we need to figure out is it a geometric or arithmetic? It's going down by 2 every time. So that would be arithmetic. Since it's going down by the same amount, there's going to be a common difference. And the recursive function would look like f of n equals f of n minus 1. And then since we're subtracting 2 every time, right, it would be minus 2. We need to tell me where it starts, and the first step here is f1 equals 5. So that would be the recursive part. Now for the explicit equation, we would have y equals, and then our common difference would go in front of the x, so that would be negative 2x. And where we start goes added with a 5. So our explicit equation in this case is y equals negative 2x plus 5. Awesome. Any questions? No one is here, so I guess I'm going to move on. All right. So the next question on your exam was using this equation. And you can tell right off the bat, it goes up by 5, then 10, then 20, that we are dealing with a geometric sequence. So it's geometric, which means it has a common ratio, which means we're going to have the Yar equation. And let's go ahead and write our explicit. So our explicit equation in this case would be just like always, f of n equals f of n minus 1. And what we're going to do to this guy is we are going to multiply by 2 every time, right? So we would have times 2 right there, right? Next, we need to tell me where it starts. And in this case, f1 equals 10. Okay. Recursive equation. Now we need to plug all that good stuff into our Yar equation. So the first term is our common ratio. So we should have y equals a to the 2 to the x power, right? And then we need to solve for it, right? We need to make it true. So if f1 equals 10, I plug in a 10 for where my, 1 for where my x is, and a 10 for where my y is, to try to solve for my a. 2 times a equals 10. I know that a equals 5 in this case. And what's interesting to note is that is also our 0th term. So if you have the 0th term in a geometric function, it is your a guy, right? Your a guy is where it crosses the y-axis. And I probably should have told you all that sooner. But our final equation is y equals 5, 2 to the x power. And that should work for all of them. Awesome. Moving on. Next up, we had a recursive equation, and they wanted us to find the explicit equation. So since it is going down by 3 every time, we have y equals negative 3x. And the first term is 2, so it should be plus 2, and that was answer choice A. Interesting to note, they use f of n here, which is fine. You can use function of n to represent your y value, they kind of mean the same thing. I like to use y just so I don't get confused. All right, I'm going to accept two different answers on the next guy. And that's based on what you thought your first step was. So if you are using an explicit equation, you always want to start with your first step of being 0, actually. So when we plug in a 0, right, 1/4 to the 0th power is 1, so our first step would be 2. So 0, 2 for the first guy, and we don't need the 0 part, right, because we're just looking for the pattern. So our first step is 2. Our second step would be 1/4 raised to the first power, which would be 1/4, which would be 1/2. And it goes down from there. After that, 1/8 and 1/32, right? Because it's going down by 1/4 every time. The other way to do it would have been starting at step 1 instead of step 0, which isn't correct for explicit equations, but I'll go ahead and give you credit because I never really explained that. You'd start at 1 and you'd be a step behind. So you'd have 1/2, 1/8, 1/32, etc. Right? I believe those were answer choices D or B. I should accept both as full credit. Moving on, we have next up on the list, we have the 6th term of 4 plus 8n. So we plug in the number 6. Whoops. Where the n is, 6 times 8 is 48, plus 4 is 52. Correct answer. All right. For this guy, what I needed to do was I needed to make an explicit equation for her basket making. It says she started with 13. So that's my y-intercept. That's what happens on day 0 is plus 13. And then she makes 12 more baskets every day. So 12 times how many baskets she makes? 15 times 12 is 180 when I plug that guy in right there. So we have 180 plus 13 is 193, which is problem choice A. Nice. This practice exam is starting to seem kind of easy now, hopefully. All right, number 7, we want to find the 50th term in the sequence. So we're going to need to write an explicit equation because I don't want to do step by step. We got y equals a times x plus or minus the intercept, which in this case is 5. All right. A in this case is going to be a -7. So we have y equals -7 times x plus 5. If we were looking for the 50th sequence, -7 times 50 would be -350 plus 5 should be -345. All right. Number 8. F of n -1 plus 10, and our first term is 4. So they want us to go from the recursive to the explicit here. Our ratio is plus 10, so we have y equals 10 times x, and our starting term in this case is 4. All right, plug in that 20, we get 200, plus 4 is 204. Correct answer for number 8. All right. 9, we're going to have to make a table here of n values and f of n values or y values. So our n values should be 0, 1, and 2. And that gives us a table, right? And when we plug in a 0 for 2, 2 raised to the 0th power is 1. 1 times 10 is 10. 2 raised to the first power is 2. 2 times 10 is 20. 2 raised to the second power is 4. 4 times 10 is 40. 40. Awesome. Excellent math, Mr. Cartwright. All right, that brings us to the end of the lesson video. Please return to the live discussion. Thank you very much.